makes this curved graph. All right, so we have 1, 2, 3, 4, 5, 6, 7 things here. What we're going to do is in the middle of that table, I'm going to put 0, okay? And in the middle of that table, I'll talk about when you're doing these later on, how you pick that value. It is going to be where the function is undefined. Okay, what do I mean by that? When you're dividing, what number can you not divide by? 0. And so what that's going to mean is it's going to make the function undefined. So I'll talk about what that looks like on a graph. What we're going to do is to the bottom, we're going to pick 3 positive values and 3 negative values. And I think just to be easy, let's pick 1 and 2 and 3, and to be symmetrical, let's pick -1, -2, and -3. Okay, so another name for the inverse function is the reciprocal function. What is a reciprocal? Let me back that up. What if I said, hey, what's the reciprocal of 5? What would you tell me? 1/5. Yeah. So does it make sense why maybe we call it a reciprocal function? Because we're doing 1 over that value. Okay. So if I wanted to plug in for this, I'm just doing 1 divided by -3. Now, for graphing purposes, let's round. We're going to round it because on the graph, maybe you know where 1/3 is, but let's just divide it. Would you put that in your calculator? Some of you know it exactly already. What's 1 divided by -3 as a decimal? Yeah, it looks like that, right? Okay. All right, so now we're going to go to the next one. -2 is -1/2. Okay, we better get this one right. What's that as a decimal? -0.5. All right. 1 divided by -1. 1 divided by -1 is just -1. Okay. Now, 1 divided by 0 we can't do, right? So you can write undefined here. What's 1 divided by 1? It's just 1, right? I'm just putting those x values into my equation. 1 divided by 2 is 1/2, 4.5. And for my 3, 1 divided by 3, or 0.3 repeating. Okay, now let's go to the graph. So let's put our points on there. -3, so we're going to go over -3 and down 1/3. So you're going to put it really, really, really close to the x-axis. -2, -1/2, so you're going to put it halfway in between. On -1, -1. Okay, now you might think, what? What does that mean? Look at what I showed you yesterday. That's just giving the portion of the graph that's over here, okay? And what would happen is if you start taking the reciprocal of numbers that were between 0 and -1, I want you to think about that. You flip the fraction around. Like, what's the reciprocal of -1/2? Yeah. And what's the reciprocal of like 1/4? It would go to 4. So as I get closer and closer to 0, these are going to get larger and larger and larger. So what I want you to do with these points is I want you to draw a curve. And there's 2 things your curve needs to do. It needs to approach, but it will not cross the y-axis like that. And it needs to approach, but not cross the x-axis. So it's a curve. Okay? And you're just making sure that your curve doesn't touch those 2 things. All right, let's do the same thing on the other side. If I would plot my point, here's 1, 1, 2.5, it's going to make a similar curve, and 3.3. So on this side, you're going to make your curve approach but not cross the y-axis from this side. Okay. So it's very different than something we've seen before. All right, so next. We haven't talked about the words domain and range for a while, but here's what I want you to look at. Domain are the x values on the graph. There's one, we can put anything we want in here, but with one value made it undefined. 0. So the domain, I'm going to say, is all real numbers. However, x cannot equal 0. Okay, now, do you notice on the graph, let's look now on the y values. There's also another number that y is never going to reach. Do you know what it is? Some of you know. It's 0. No matter what happens here, let's start getting really, really big, okay? If it was 4, wouldn't this be 1/4? And this was 5, it would be 1/5. And let's say I put in 100, it would be 1/100. It's going to get really teeny tiny, but it's never, ever, ever going to get to 0. And so the range is the same thing. The range is all real numbers, but y can't be 0. Okay. From Algebra 1, who remembers seeing that word before? Just give me a thumbs up if you have. I want to know how much I have to talk about it. Have you seen this word before? Okay. So what an asymptote is it's a line that the graph never reaches. So this has 2 of them. Let's highlight them. Remember how when we were graphing, I said, hey, make sure it does not cross the y-axis. What kind of line is that? Starts with a V. Vertical line. Good. Okay. So there is a vertical asymptote. That's a funny word. And that vertical asymptote is at x equals 0. That's a vertical line. We write vertical lines as x equals. Okay. There's another line that this graph doesn't cross. It's this one. What kind of line is that? Starts with an H. Horizontal. So we call this a horizontal asymptote. And it's at y equals 0. Okay. So that's what my graph looks like. I want you to just kind of make some observations about the graph of the inverse function because its shape is going to stay the same when we start to put some different values in. But the general shape of these 2 curves is going to change. What might change now is that if we move it to the right, the asymptote moves to the right. If we move it to the left, the asymptote moves to the left. Let's say we move it up. Guess where that horizontal asymptote goes? Up or down. And so if you know this kind of shape, then it kind of makes it easy, I think, when we're graphing. So look at the curves, make sure you're knowing that it doesn't cross those lines. Number 2, to summarize, what are x and y values of the function that the function approaches but never reaches? What did we say? 0. Both are 0. And then a question for you. Do you guys know what quadrants are? This is quadrant 1. I'm going to write them with Roman numerals. This is 1, and then we go counterclockwise. This is 2. and this is 3, and this is 4. Okay. Do you notice that the graph shows up here and here, but it doesn't show up here and here? I want you to think about why. What kind of number is 1? Is it positive or negative? Positive. And over here, x is positive. If you take a positive number and divide it by a positive number, what are you going to get? A positive. That's why you're not going to see it show up over here, okay? Because when I take a positive and I divide by a negative, it's going to be negative, or it shows up down there. Okay. How we feeling? Not so sure. So let's flip over to the second page that I gave you. Okay, now I would like us to really try to visualize first. We're going to use, I'm going to pop the graph up on Decimus as well, but you really want to look at the equation. And we're going to identify where the asymptotes are. Okay? So, negative 1 over x. Ooh, do you guys remember what a negative does when you put it in front of a graph? You do? Good. What does it do? It flips it. Yeah, it flips it over the x-axis. So I'm going to put it up on Decimus a minute. Actually, I'll put it on my graphing calculator. That way we can see it under the screen and everything. What you're going to see is the graph is now going to flip over, and this part is going to go down here, and this part's going to go up here. So I do that. All right, are you seeing that? So let's sketch a picture of our graph. Where are the vertical and horizontal asymptotes on this one? Get rid of that glare. Does it look like the same thing? Okay, so I am going to flip this graph around, and like on this one, I am going to have maybe it go through the point 1, negative 1. I'm going to do this. How about 2? What's negative 1 divided by 2? Negative 1 divided by 2, what is that? Yeah. So like it would be right here. And I thought I would put, what happens when you flip 1/2 around? What do you get? 2. I'm going to put that point on so you can kind of see a little bit better of the curve. Okay, so this goes over here. Still undefined there. Let's go the other way. What happens when you flip negative 1/2? Flip negative 1/2 around. It becomes 2 over 1, negative 2, but there's a negative over negative that becomes a positive. So I have the point negative 1/2, 2. If I plugged a negative 1 in, negative 1 divided by negative 1 would be positive 1. So I'm going to plot the point -1, +1. And I should have left more space. Let's do -2. What's -1 divided by -2? Isn't it +1/2 or 0.5? Okay, so we'll draw our curve, make sure it doesn't cross those axes. Okay, the domain and range do not change. So the domain is still all real numbers. I'll abbreviate, or I'll put the symbol for numbers, but what is x not equal to? 0. And the range is still all real numbers. But y is not equal to 0. All right. Let's look at question 2. What's different in question 2? Instead of an x on the bottom, what do I have? X plus 3. Okay. I don't know if you remember this. This is good review for transformations. X is a liar. This moves the graph. What direction? Left 3. Let me show you a picture of your graph. Maybe you'll be able to see Decimus better than my graphing calculator. On your graphing calculator, you got to make sure that it goes on the bottom. Okay, weird. What happened? You want me to graph 1 over x so you can see the difference? Let's graph the original. That's the original. Now I did x plus 3. It moved, right? Left 3. Quick question for you. Where do you think the vertical asymptote goes then? It was at 0. The y-axis is, yeah. So the x-axis is still the horizontal one. That did not change. You're absolutely right. So it's still, but do you see how it moved over? So it used to be here. And it's essentially like it moved 1, 2, 3 over. Now it's right there. Okay. All right. Let's just do a sketch. We're not going to do a table for the points. Let's just do a sketch of our graph, right? So instead of making our asymptote at 0, would you go to -3 and would you make -3 like a dashed line? It's not a real line because it doesn't really show up on the graph, but it's now where the graph moves. Okay, we're going to just draw our curve then. It's just a sketch, guys, and we're going to make it approach that asymptote and then approach still the y-axis on that side. And then we're going to do the same thing on this side. Okay, guess what? The domain isn't all real numbers except 0 anymore. What do you think it is? All real numbers except -3, right? Because it doesn't cross at -3. All right, so domain, all real numbers. X is not equal to -3. And we said the y didn't change. So all real numbers, y still does not equal 0. Okay, this is the last one we're going to do. Look at question 3. So this time, I have a +4 on the end. Anyone remember what that does? It moves good. I'm going to write here what we did. This moved the graph left 3. This moves the graph up 4. Let's take a look. Okay, so we have 1 over x. I'm going to take this off now. 1 over x. Watch what happens when I do plus 4. How did it move? Up 4. And so instead of the y-axis, let's go ahead and let's put a horizontal line dashed at 4. Did the x change at all? No. Okay. All right, let's sketch. So for question 3, we're going to move it up 4. We're not going to change the center of the graph, and let's make our 2 curves. So the curve here still approaches the y-axis, but this time we make it approach 4. And on the other side, same deal. We make it approach 4 and then the x-axis. And then our domain is all real numbers. X is not equal to 0. How about the range this time? What? All real numbers, y, but yeah, right value, good job. All real numbers, but y is not equal to 4. Very nice. Okay,